Our objective, I can simplify and evaluate algebraic expressions using order of operations. Read together. One, two, three. I can simplify and evaluate algebraic expressions using order of operations. So today we're going to take a little break from polynomials, if that's okay with you guys. And we're going to go back to basics. I want to make sure I cover a couple things that I've seen some of you make simple mistakes. Hopefully this will clarify it. And also in regards to order of operations, the same thing. Before we get more into evaluating expressions, I want to make sure that we understand our order of operations. Okay? So, you okay? All right. So, essential question for today, how do I evaluate and interpret algebraic expressions? We'll get back to that at the end. Now, expressions. I usually, like any concept, I try to introduce it in a different way, kind of like with polynomials we did, the little pet shop and so on and so forth, right? So, for expressions, just to clarify expressions, we've been seeing expressions, but this is just to clarify a little bit more. Expressions could be presented in a different way, such as, let's say, a student of this block comes up to me and he says, Sergio, he says, Mr. Q, my parents want to buy you guys tickets to a concert, to the entire period 5 class. You just need to, they just wanted to know if you can arrange a field trip for that. I'm like, all right, let's see with the office. I go to Mr. Lopez. He says yes, so then we get tickets. So here we go to the field trip. And we arrive there, and then all of a sudden we forget, like, we're so excited at the fact that we're not come to school that we just go and we don't even know who's presenting, right? So then we get there, we're front row, right? Bam. So, yeah, he gets his VIP and everything. So, so anyways, so here comes the music starts playing. So then we're like, all right. So this guy comes out and everybody's looking at Sergio because they're like, Sergio, who's this guy? So we're like, so we're like, yeah, 3 hours of this, yeah. So anyways, this music is like what, like classical, opera, or what? Kind of somewhere in between, right? Be nice. So, but then he says, I have a special guest. So he brings his special guest out. There is, damn. Let's find out. So this guy is Magic, the remix, right? So, here's a question to you guys. We started off with classical or opera, is that correct? But as soon as they added a different type of artist, it became something else. What did it become, like reggae or hip-hop, whatever you want to call it? Well, same thing with mathematics. When we first started in our mathematical career, yeah. We started our mathematical career, the first thing that we were introduced to were numbers. Those were called numerical expressions. So we covered numbers and all the operations, is that correct? From there, when you got to, now in first grade, now they're introducing the unknown, but hopefully by third grade you were introduced to variables, and as soon as you got that, those are called algebraic. So some of the examples I can give you for those is, let's say they gave you the number 2, but as soon as you add a variable, 2x, it becomes algebraic. When you add operations such as 2 plus 1, how can we make it algebraic? 2x plus 1 or 2 plus x, something like that. Is that correct? As soon as you add a variable into the expression, it becomes an algebraic. How about, let's see, 2 minus 1? 2x minus 1. How about 2 times 3? 2x times 3. How about 2 divided by 3? 2x divided by 3x. Okay. Or y, whatever the case. So therefore, do you understand what algebraic expressions are, right? All right, that's just to clarify. So, algebraic expressions, write this down, please. They are expressions that contain three things: variables, constants, and operations. Expressions that contain what? Variables, constants, and operations. Algebraic expressions are what? Expressions that contain variables, constants, and operations. Algebraic expressions contain what? Variables, constants, and operations. Algebraic expressions are expressions that contain variables, constants, and operations. Example: x plus 3, m minus 7, 2 times y, k squared divided by 5. All those are examples of algebraic expressions. Non-examples: x plus 3 equals 10, 15 equals m minus 7, 2 times y is greater than or equal to 12, and 2 is greater than or equal to k squared divided by 5. Copy that, please. So, according to the definition, it says it contains variables, constants, and operations. Do all these have variables? Yes. Do they have constants, which is a number without a variable? Yes. Do they have operations? Yes. So, if these are algebraic expressions, tell your neighbor why these are not algebraic expressions. Okay, I heard because these are equations. Yes. What else? They are, yeah, they're not equal, which means they are inequalities. So therefore, the most important thing to remember that algebraic expressions have variables, constants, and operations, no equal sign or inequality signs. Steps, copy this. Oh, my bad, sorry. There it is. Copy that. All right, before I continue to the steps, let me show you just to clarify about terms and coefficients and constants. So here we go. Terms, we said, of an expression are the parts added or subtracted. We know them as monomials, right? Like terms are the terms that have the same variable with the exact same exponent or raised to the same power. Constants are just numbers without the variable. For example, look at this expression. Look at this expression. Oh. This expression has 4x minus 3x plus 2. 4x and 3x are like terms. That means this one is a constant. Now, out of these, there's coefficients. We said coefficients are numbers that multiply the variable. So the coefficients here are what?
1.
Everyone? Coefficients are 4 and negative 3. 4 and negative 3 are my coefficients here. Are we there so far? All right. However, what if an expression does not have a number in front of the variable? What would be the coefficient? 1. So we know that, right? So, for example, if I get x squared plus x, the coefficients are 1. So far, so good? All right. So look at this. Parts of an expression. How many terms are there in this expression? Everyone. Let's see. 1 begins here, one part, and as soon as you see an addition or subtraction sign, it ends. That's 1. That's 2. That's 3. That's 4 parts. So it's a 4 term. Identify the like terms. What are my like terms? 6x squared and x squared. Identify the constant. 4. 4 is a constant because it doesn't have a variable multiplying it. And what are my coefficients? 6, negative 5, and 1. Not x, and 1. Everybody got that? The reason I'm going over this because still some of you are getting mistaken with your terms. Make sure you clarify that. So copy this one, please. X squared plus 10x minus 3 minus 8x, and answer the questions, please. How many terms? Identify the like terms, identify the constant, and identify all coefficients. Go. What? Correct. So yeah, so this expression has four terms. Like terms are 10x and negative 8x. Constants negative 3, 10, negative 8, and 1 are my coefficients. All right? So with that, to copy these steps, please. Steps. To simplify and evaluate algebraic expressions, number 1, substitute given values for the variables. Once again, step 1, substitute given values for the variables. Step 2, use the order of operations. Step 3, use the cat properties to combine like terms. And step 4, simplify. Step 1, substitute given values for the variables. Step 2, use the order of operations. Step 3, use the cat properties to combine like terms. Step 4, simplify. Copy that. Okay, we got this, right? All right, so check this out. So like I said, today we're going to take a break from polynomials. We're just going to go back to basics, very basic. So here we go. So everybody go like this. Turn and look at me. Go like this. So like that, you can bear with me. See what I did right there? So you can bear with me. All right, here we go. So pens down, eyes up here. So taking you back in time, your instructor, they presented order of operations. They're like, okay, kids, order of operations, yeah. Yeah, so they presented as PEMDAS. Here we're going to look at it in regards to parentheses and powers, or parentheses, another name for those are group symbols. So some teachers present it as GP or GE, and then the order of operations that follows. So the next step is multiplication and division, and since we might have some that have both present, we start from left to right, whichever comes first. That's something some of you are still having struggle with. I don't know why. Next, addition and subtraction, same thing. We always go from left to right, whichever comes first. Now, grouping symbols. Let me elaborate on this one. Let's think about different types of grouping symbols. Who can give me one set of grouping symbols? Grouping symbols. Boss, go. Bam. Parentheses. That is correct, yes. Brackets. They're brackets. Another. Who can think of another? Yeah. The thingy-majig. Like this. The absolute value. Very good. How about let's see. How about the set brackets, the solution set? Okay. How about this one? That's also a grouping symbol. How about this one? A fraction bar. Yes, the fraction bar is known as a grouping symbol because it groups any expression in the numerator, separating it from the denominator. So with that said, let's go to some computation. Here we go. Copy these, please. Example 1A and 1B. Like I said, today's only going to be like review. Hopefully this will refresh your memory. But be careful. Some of these are so simple that you might skip something and make a small mistake. So be careful. That's where I want to get to. Copy those, please. Example 1A is 15 minus 2 times 3 plus 1. Number 1B is 12 plus 3 squared plus 10 divided by 2. So let's do these together since we already know how to do these. I'm going to write parentheses, power, multiplication, division, addition, and subtraction. Do we have any grouping symbols? No. Powers. Multiplication, division. I'm going to scan that from left to right, right here. So therefore, this becomes, everyone, negative 6 plus, bring down the 15 and the 1. And then addition and subtraction from left to right. 15 minus 6, that's 9. Plus 1, that is 10. So far, so good? Next one. Any grouping symbols? No. Any powers? Yes, this is 9. Bring everything else down. Multiplication, division from left to right. There's 1 right here. This becomes 5. Bring the rest down, and it's all addition from here. Therefore, this is 6. My goodness. What do you guys have for lunch? You guys all right? All right. What? Okay. All right. Copy this one, please. Example 1C. Let's see how you do with that one. Yes, it does, because it has a C for cents. Oh, I thought you said cents, like a dollar. Cents? No, never mind. All right, here we go. Parentheses, power, multiplication, division, addition, and subtraction. So let's start. So we have grouping symbols. How many? 2. The parentheses and the fraction bar. Therefore, the fraction bar is telling us to focus on the numerator or the denominator. Which one are we focusing on? Numerator. Okay, so let's start with the numerator only. Do we have any parentheses in the numerator? Yes, but we can't do anything about it. Powers? No. Multiplication, division? Yes. From left to right, 2 times negative 4, that's negative 8 plus 22. And, of course, the last from left to right, that becomes 14. All right, now let's go to the denominator. Any parentheses in the denominator? No. Powers? 16 minus 9. 16 minus 9 is 7. And we simplify. What is 14 divided by 7? 2. Are we doing good? All right, let's continue. Here we go. Copy this one. Do this one by yourself. You got 20 seconds. Go. Once again, I'm going to go over this one because some of you skipped steps and some of you actually didn't skip steps, but you made a mistake. Here we go. So we have grouping symbols. Yes, but we can't do anything about it. Powers, no. Multiplication, division, yes, I'm going from left to right. Here we go. I'm going to focus on this one. 8 divided by 1/2 becomes 8 times 2 over 1. Is that correct? So this becomes 16. Bring down the multiplication at the end. This becomes 48. I told you guys that this is so simple. Some of you are going to make mistakes. So you need to pay attention to the little signs and the little order of operations. Let's do another one. Here we go. Copy this one. Example 1E. Simplify the expression 3 times square root of 50 minus 1. Let's see. I'll give you guys some time for that one. I'll give you 30 seconds. How about that? Copy that and go. Now check this out. Correct answer is 21. But this is where some of your brain couldn't go forward. You thought that this was this. No. Some of you, I said. I didn't say all of you. So this is not that. This is 3 times square root of 50 minus 1. Does everybody see that? So make sure you pay attention to those little things. So inside the grouping symbol, we have 50 minus 1, that's 49. square root of 49 is 7 times 3, that's 21. So when there's two expressions next to each other, it's multiplication. We did. What's that? No, that's when you have the E, but we don't have the E. We have P, P, M, D, A, S. All right. Copy this one. Do that one by yourself. You got about 30 seconds. Go. All right, check with the neighbors, see what they got. Okay. Let's see. Correct answer. Correct answer is 1. Oh, my bad. Sorry. 5 and 1 over 11. Oh, sorry. There it is. 5 and 1 over 11. Hands if you got that. Okay. Let me elaborate so that you guys can see. Parentheses are grouping symbols. Yes, all over the place. We'll start in the numerator. Therefore, what can we do in the parentheses? Add. That becomes 7 times negative 8. And at the end, we have multiplication, division. This is negative 56. Are we there so far? Denominator. Powers. Yes, that becomes negative 2 times negative 2 times negative 2. So that becomes negative 8 minus 3. Is that correct? Negative 8 minus 3, that's negative 11. Since these are the same sign, the answer is a positive. 11 fits in there how many times? 5 and 1, 11. No, let's just go to the next step and simplify to lowest terms. Copy this next one, please. We're going to go into evaluating expressions. Copy this. Only. Example 2. Just copy the black text only. Go. Okay, example 2. Here we go. Once again, a shop offers gift wrapping services at 3 price levels. The amount of money collected for wrapping gifts on a given day can be found using the expression 2B plus 4S plus 7D. On Friday, the shop wrapped 10 basic packages B, 6 super packages S, and 5 deluxe packages D. Use the expression to find the amount of money collected for gift wrapping on Friday. So, what is the original expression that they gave us? 2B plus 4S plus 7D. First thing you do is write that one down. 2B plus 4S plus 7D. Second thing I want you to do, underneath that, you're going to rewrite the same expression but without the variables. Instead of a variables, open parentheses. So this is 2 parentheses plus 4 parentheses plus 7 parentheses. And all we have to do is substitute values to evaluate. Let's see. Let's go back to the original problem. It says, on Friday, the shop wrapped 10 basic packages B. So instead of 10, we write what? 10. Next, 6 super packages S. So instead of S, we write 6. And at the end, 5 deluxe packages D. Instead of D, we write 5. and then we just follow order of operations. Since we don't have any, we can't do anything on the, inside the parentheses. There's no powers. Multiplication, we go from left to right. This is 20. This is 24. And this is 35. Addition and subtraction from left to right. Be nice. 20 plus 24, that's 44. Plus 35, that is 79. Therefore, the shop collected 79 buckaroonies for gift wrapping. Why am I using arrows? Because we're not in equations, we are in expressions. Ma'am. Okay, home play for tonight found on pages 54 and 55 only. All right, have a good one, everyone. There's tutoring today. If I don't see you guys tomorrow. Bye.